Okay, that out there is the Tetons Range at sunset. The thing you notice about the Teton Range is they stick up out of the plains something wicked. And then you've got this thing over to the side, which is actually a glacial moraine. Which just gives you some interesting idea of the topology of this place. You've got this huge scarp edge sticking up out of what is essentially a completely flat plain, and then you've got this glacial moraine that's just left in the middle of the plains. Now, there's actually quite an interesting story to this. So what happened about 15 million years back is a very hot part of the core of the Earth. Things that get hot expand, very much like if you've got hot air in a balloon. The reason it rises is because it's hot and it becomes less dense when it's hot, and then it tends to rise through the mantle, and as it does that, of course, it cooks all the rock around it, so all this rock on either side will actually be sort of incandescent, and eventually it reaches the lithosphere, which is actually, this is the sort of crustal plate. It's exceptionally thin. It's about 50 miles thick or something. And just to give you some idea of that, the 50 miles is what you can drive in about an hour. It's also about half the distance to space, if you could drive upwards, that is. Anyway, so once you've got this huge hot spot, the ionosphere is relatively plastic due to pressure and temperature, relative to the lithosphere, which is actually really quite hard. So once this lava reaches the magma, once this magma reaches the lithosphere, it can't easily go through it because the lithosphere is significantly harder. And so what actually happens is it sort of stresses the lithosphere, and this is what happened about 15 million years ago. And the stressing of the lithosphere caused those mountains to be pushed up about 5 million years ago. Now, as it did that, it did it by sort of stressing the lithosphere. So what you've actually got is the magma is pulling this, and as it does so, this bit is pulled down, and this bit is pushed up as the two plates lay paths to each other. And this would of course be the sort of sedimentary shit that we've seen coming all the way across America. And in the meanwhile, the bit in the middle has filled up with sedimentary junk, which is why when you actually look around here, you're on a dead flat plain, and then you've got these mountains that just stick up out of nowhere. Okay, so this was about 5 million years ago, and then as this hot spot eventually stresses out the lithosphere enough that it cracks, and this is what happened about 3 times over the past 2 million years, and that was the supervolcanoes in the Yellowstone area, and they blew huge amounts of ash all over America. Okay, so this is the ash layer that was blown up by the one of the Yellowstone eruptions. It's erupted about 3 times over the past 2 million years. And the current reckoning is from seismic data that the hot spot under Yellowstone is basically solid now. And even though the Earth is still bulging there as if it's going to erupt again, the thing is that the liquids and solids have different acoustic properties. So if you get a big earthquake, say over here, and you've got a range of seismic detectors over here, you can actually tell if things underneath the surface are solid or liquid depending on how the sound arrives on the other side. So the reckoning is that the magma chamber under Yellowstone is now mostly solid. So that was about 2 million years back. Then only, obviously over the last 100,000 years or so, we've had several glacial periods. Okay, for about the last million years or so, we've had ice ages about every 100,000 or so years. Now, that huge pocket of magma that's come up under Yellowstone has actually caused a bulge in the Earth's crust of about half a mile or so. And what that practically means is, obviously you can see by the mountains, that the higher up you go, the colder it gets. And just so you know, those things rise about 1.5 miles above the plain. So we're at about 7,000 feet now. The top of those things is about 13.5. Anyway, so there's this huge bulge in the crust under about where Yellowstone is, and extends well down to the Teton Range. And what this means is, when the last ice age came, this place got whacked with huge glaciation. And we know that because the Yellowstone, which is about 50 miles that way, one of their glaciers came all the way down and dumped this glacial moraine. This is like all the dirt and shit that you get at the end of a glacier at its furthest extension. And I know myself, because I actually went up on there yesterday, and you can see all the rocks and shit brought down from Yellowstone in this glacial moraine. And indeed, you can even see the residual artifacts of glaciation in front of the Tetons. There's a big lake called Jenny Lake, which is actually about 400 feet deep, which was originally carved by glaciation. And indeed, it was originally 800 feet deep, but half of it's been filled up by sedimentation. And that's just at the foot of the Tetons over there somewhere. So, the question to my creationist friends is, what's their explanation for all of this? Why do the Tetons rise out of the plateau like that? Why is Yellowstone to the north? What's their explanation for it, and the volcanism there? And why is there a great big glacial moraine in the middle of the Tetons plateau, which is full of rocks from Yellowstone? And indeed, what's their explanation for why there is a 400-foot deep lake at the foot of the Tetons? I'd really like to know if any creationists fancy taking this up.